All right, chemistry students, here are some of the questions for the electronegativity worksheet. Okay, electronegativity is a number. Let me get rid of this stuff here. Check that all cleared out. All right. Electronegativity is a number that represents how much an element attracts electrons to itself. The electronegativity difference is the difference between the electronegativity values for two different elements. It can be used to tell us whether the bond is nonpolar covalent, polar covalent, or ionic. A small electronegativity means electrons are shared equally, while medium difference means the electrons are shared unequally. The largest electronegativity difference means electrons are transferred as in ionic compounds. And then we have this chart right here. We're told to use the following chart to determine which type of bonds are in these compounds. So you have the electronegativity difference is if it's less than 0.5, if it's from 0.5 to 1.7 or greater than 1.7. We have the types of bonds that are indicated by those differences. So if we have an electronegativity of less than 0.5, the bond type is nonpolar covalent. Okay, and that means that electrons are being shared equally or almost equally. Okay, if the electronegativity difference is 0.5 to 1.7, that means it's called what we call polar covalent, which also means that electrons are being shared unequally. In other words, one is being pulled harder than the other one. Okay, if we have an electronegativity that is greater than 1.7, that is an ionic bond, and that means electrons are being transferred, okay, like the ionic compounds that we talked about in the last unit that we went over. Okay, question number 1, which element has the highest electronegativity? You'll notice on the periodic table, electronegativities get higher as you move from left to right on the periodic table, and they get higher as you move up. So in the upper right hand corner, you've got the highest electronegativity is fluorine, 4.0. Okay, so the element is fluorine. Okay, do metals or nonmetals have a higher electronegativity value? Okay, well, we just took a look at the chart, and the elements with the highest electronegativity are found here in the upper right hand corner. You'll notice that group number 18 is not on this periodic table. We'll talk about that in another question, but this is group number 17 right here, and this is group 16, 15, and 14. These are the ones the nonmetals that we will use for the electronegativity of covalent compounds. Okay, so nonmetals have a higher electronegativity. The reason why is because they want to gain electrons, okay, in order to have a stable octet. Because nonmetals, let's enlarge this a little bit here. Because nonmetals want to gain electrons. And stable octet. They want 8 valence electrons. They want to be like the noble gases, group number 18. So that's why we've got that. Okay. Lower electronegativity, these are the metals. Metals have lower electronegativity because they want to lose. Okay, they want to lose electrons. They don't want to gain electrons. High electronegativity numbers means that they want to gain electrons, but metals want to lose electrons in order to gain the stable octet. So remember, these are you know, this is like group 1. Remember, they become +1 ions. Group 2 becomes +2 ions. Group 13 becomes +3 ions because they want to lose those electrons. Okay, they want to lose their valence electrons in order to have the stable octet. Okay, and then which family does not have electronegativity values? I kind of was talking about that previously. The group 18 are not even on the list here. They're not even on this chart because the noble gases, group 18 or family 18, already has 8 valence electrons. Okay, it already has a stable octet. You've got some examples here to determine whether it's polar covalent, nonpolar covalent, or ionic. Okay, so all we have to do is just compare the most electronegative element to the least electronegative element, find the difference between those two, and that will tell us what the bond type is. So we've got sulfur and chlorine in this first example. Chlorine is the most electronegative. It has an electronegativity number of 3. Sulfur is 2.5. Okay, and those numbers came right off this chart right here. Okay, right off the chart here. Okay, and we got a difference of 0.5. 3 minus 2.5 is 0.5. Use this chart here. Okay, if it's 0.5 to 1.7, okay, right here, 0.5 to 1. That means it's polar covalent. Okay, and that's what we got right here, polar covalent. The next one is where you've got phosphorus trichloride. So we've got P for phosphorus and Cl. We already know from the previous problem that Cl is 3, but what is phosphorus? Let's take a look up here. And phosphorus is, let me clean this up a little bit. So phosphorus is right here, 2.1. So that's less than the chlorine. So phosphorus is going to be 2.1. The chlorine is 3.0. And all we're doing is we're looking at the symbols. We're not paying attention to how many we have. We've got 3 there. We've got 2 there. We're not doing that. So all we're doing is we're just comparing the numbers of electronegativity for the element. Okay, so we're going to go 3.0 minus 2.1 equals 0.9. Okay, and we just go back to our chart. Okay, that's between 0.5 and 1.7. That's going to be polar covalent, just like the first one. Polar covalent. Okay, the next one is cesium, Cs, and fluorine. Okay, so let's look at our numbers up here. Cesium, clean this up here, and fluorine. Okay, so what do we have here? Well, I always look in the upper right hand corner and to see if we've got 2 nonmetals, but cesium is not there. Cesium is way down in the lower left hand corner. It's 0.8. Okay, and fluorine is way in the upper right hand corner. That's the one that has the highest electronegativity, 4.0. So our least electronegative is cesium. Cesium is the least, and that was 0.8. And fluorine is the most electronegative in this case, is 4.0. Subtract the smaller from the larger, and we get 3.2. 3.2. Well, that's going to go on this chart right here, greater than 1.7. That means that's an ionic compound. That's a metal combined with a nonmetal, and that is ionic. Okay, and let's take a look at one more. We've got chlorine combined with chlorine. Okay, so when it's the same one, it's a diatomic. Okay, that means that it combines with itself, and in that case the 2 does matter. If it's not combined with a different element, you have to look at it. Okay, it says chlorine with chlorine, so they're going to be the same, and chlorine has an electronegativity number of 3.0. So we would say chlorine is 3.0 and chlorine is 3.0. Subtract 3.0 from 3.0 and gives us a difference of 0. And of course that's going to be less than 0.5. That means it's nonpolar covalent. Okay, so we will write, nonpolar covalent. Okay, so that's how you do those. And then you've got a few more left there to do. Contact your chemistry teacher if you have questions on this. Okay, get in those Google Meets and get those assignments turned in. Good luck on this.